Alright, well, welcome to the next video for CSE 222. We're going to talk about structures in this video. So, structures are key to everything we're going to try to do this quarter. We're going to be learning data structures, which is basically how we can take collections of data and treat them as a single entity and organize them in the memory of the machine and so on and so forth. And so the structure statement in C supports that. It's a way to effectively define a new type of variable that consists of other variables. So this is an alternative to what we normally think of as parallel arrays. So let me go back to this sample code from the first video where we're reading in a line of input and we were breaking it into tokens. So we were working with this movie database where we have 5 fields on each line, and we've got a name, release date, revenue, runtime, and a description. So this is a text field. This is we're going to treat it as a text field for now. This is a number, and this is a text field. So if we wanted to save this information in the memory of the computer, one option is to use a series of 5 arrays. We could have an array called title, an array called release date, an array called runtime, and so on. And we could read in this data and store all the titles in a title array, all of the runtimes in a runtime array. And then if we wanted to, pull out information on movie 17, its title would be in title bracket 17, its runtime would be in runtime bracket 17, and so on. But if we wanted to, pass our movie database to a function, we would have to pass all 5 arrays, and we have to make sure that, we pass them in the right order, and so on and so forth. So a structure will let us define a new type of variable, and so let's make a structure to store movie information. So the keyword is struct, and I'm going to name my structure movie, and then I'm just going to list the types of things that are in here. Well, the title, I'm just going to make a title field with 64 characters. We should, make these variable length, but I'll keep it simple for now. So our title is 64 characters. Release date, I'll just make that a character array for now. And then our third field is going to be a revenue, so that's going to be an int. And then our runtime will be an int. And I'll just make our synopsis a big field of 512 characters. So this is a new type of variable, a struct movie. It's got 5 fields to it: title, date, revenue, runtime, and synopsis. Alright, so here's what we're going to do. We're going to do the same thing we did before. I'm not going to worry about record numbers too much. We'll flush the header. We'll read a line. We'll get rid of the null terminator on the end, bump up the record number. Alright, so word equals string token, buffer, comma, pipe. So let's copy, let's make a struct movie info. So movie info is a variable, and its type is a struct movie. So movie info contains all 5 of these things. And if I want to get to any of these individual fields in this variable, I can say, for example, movieinfo.title, and I get to this. I can say movieinfo.revenue, and I get to this field. So here's what I'm going to do. I'm going to grab my first token using my string tokenizer, and then I'm going to copy into movieinfo.title that word. And I'm not going to bother with these print statements. So now I'm going to grab the second field, which is the release date. So let me put some comments in here. So that'll be the release date, and I'll string copy movie info dot date word. That should be date. All right, so let me set this up. Alright, so I'll string copy into movie synopsis. So the first field we parse is the title. I'll copy that into the title field in movie info. The second field we parse is the release date. I'll copy that into the date field of movie info. The third field we get is revenue. And I've said that revenue is going to be an int, so we need to parse it. We need to change it from a string into an integer. And so I'm going to do this. I'll do an scanf on word %d movie info dot revenue. So now I'm asking scanf to look at this word, convert it as an integer, and save the result in this field, the revenue field of movie info. And then I'll do the same thing for runtime. And then for the synopsis, we'll just copy that in directly. All right, so what's the advantage of this? Well, the advantage is that the single variable movie has all 5 pieces of information in it, movie info. And so, for example, I can say print movie info. And I only have to pass that one variable. And it's going to have all 5 of those pieces of information inside it. So let's make a print function. And I'm just going to call my argument arg so we don't think that movie info is particularly critical. So title equals %s, release date equals %s, revenue equals %d, runtime equals %d, and synopsis equals %s. So I will print out our argument dot title and our argument dot date and argument dot revenue and argument dot runtime and argument dot synopsis. All right, so I've got a function I can use to print this, and all I have to do is pass that one variable instead of passing 5 pieces of information. Now, yeah, I could just print this up here with a print statement, but if we want to do something more sophisticated with this information, we want to archive it or analyze it or combine it with other things or store it in some kind of structure, right? It's nice to be able to pass all that information with just a single variable. So let me prototype this function so we don't get complaints from the compiler. All right, so barring typos, this should give us a nice single line output for each movie in our database. So let's try compiling that. Got lots of errors. All right, so this is a good opportunity to figure out how to deal with compile errors. First thing I'm going to do is I'm going to say let's pipe this into more so that we can see one screen at a time, because we always care about the first error. But if I do this, it's not going to help. I'm still going to get all my errors flying off the screen because errors are printed to standard error. So if you want to capture standard error, use a pipe ampersand. And now it's showing me my output one page at a time. And so the first issue is struct move declared inside parameter list will not be visible outside of this. Let's go back and look at this. So here's our struct movie, and I called this a struct move. So that should be a movie, and we're not passing a pointer, we're just passing the movie info itself. So we'll do that, and this is a movie. Arg. Alright, so let's recompile, and hey, all of our errors went away, right? And we had, you know, errors and warnings and all this kind of stuff going on before, and it was just because I misspelled that name and I had a stray asterisk there. Alright, so this runs fine now, so let's say run less than movie database and put the output into more, and hey, it didn't print anything. Well, that's kind of weird. Alright, so if you run this and you're not seeing any output, try running it without more and you'll see what's going on. Got a good old seg fault. Alright, so we've got to be careful, right? In this movie database, not every record has 5 fields, right? In some cases there's only 4 fields and then there's nothing hanging out over here at the end. In some cases there'll only be 3 fields. And our tokenizer returns null. And so we need to catch that, because if we try to use null inside a string copy command, that's going to throw a seg fault. So let's do the simplest thing. Let's say we're only going to process records that have all 5 fields. So we'll grab the title, we'll grab the release date, but let's just do this. So if the record is short, if word came back null, we'll just say continue, which will take us back up to the top of our while loop, and we'll read the next line. And I'm going to do that each time that I tokenize. Alright, so let's run this, and it works well, but it eventually seg faults still. So if we do a word count, it's getting through 11,000 records before the seg fault, so something weird is going on in our file. So let's look for this record in our database and see what's going on right after that. Alright, so looking to get out is right there, and then the next record was this one. And what's happening is the first field is null, and I didn't check for that because I assumed every record would at least have a title, but here's a record that does not have a title at all. So we need to put in this check when we grab the first token also. So now we fix that, and we run on the movie database, and we get all 40,000 some records. If we look at the end of the movie database, the last one with a title is Betrayal, and that's the last record that got output. So there we go. We can read in this data, we can store it inside a structure, and then we can treat that structure like a single variable. So that's progress. The next thing we want to do is store these in an array. So we want to make an array of structures and store the entire database in memory. So let's do that next. Alright, so we're going to build an array of movie information. And so instead of struct movie info, let's store information about 100 movies in this array. And again, we could make this, you know, dynamically allocated at runtime, but we'll keep it simpler for now, and we'll just use a fixed size array. So I'm going to have my record number match the index. I'm going to get rid of this print statement down here. And here's what we're going to do. We're going to use record number as an index. I've got an array of 100 movies, right? 100 struct movies. So I'm going to copy movie info bracket record number dot title. I'll copy movie info bracket record number dot date. I'll scan into movie info bracket record number revenue. I'll scan into movie info record number runtime, and I'll string copy into movie info record number synopsis, and then I'll increment the record number. And if my record number is greater than 99, I'll break out of the loop. So I'll process 100 records, and when this gets incremented to 100, that would be the 101st record, I'll just exit. All right, so at this point, let's go ahead and print out our movie info, but this time movie info is going to be an array of movies. So let's change our prototype and let's print struct movie star arg. So that's an array of movies. And let's also tell it how big the array is, because we might not have 100 movies. So we'll pass the size of the array to our print function. And in here, if record number is bigger than 99, it'll be 100. That'll tell us how many things we have in our array. So we'll print movie info record num. So this is the size of the array. So we'll take in a star argument. And we'll print out the movie number, and then we'll do the title, release date, and so on. I'll fix my revenue typo now. But arg is a pointer to an array, and so we really want arg bracket I dot title, arg bracket I dot date, and so on. All right, relatively small amount of code change, but big change in behavior, because now we're going to read up to 100 records. We're going to store that information in consecutive elements in this array of structures. And then when we call our print function, we're passing an entire array, and our print function will go through all the data in that array and print it out. So let's see how we did. Not too bad. Conflicting types for argument print. In function print, record num is undeclared. So I forgot my second argument in here. So let me just call it size. That's the size of the array. Compiles fine. Let's go ahead and run that, and now you can see movie 0, movie 1, movie 2, and so on. And this should print out 99 movies, ending with this one. So there we go. We've got an array of structures now, and this one variable, right, movie info, contains 5 pieces of information on 100 different movies, 100 different structures. Which is much easier to work with than parallel arrays, for example, where we'd have an array of 100 titles, an array of 100 dates, and so on and so forth. So that's an example of using a structure like this. All right, let's take this just a little further. If we look at the date field, it's a year dash month dash day. and we're storing that as a string. Well, maybe that's fine, but maybe we want to, you know, eventually sort these by year or find all the things that came out between January and March. And so let's do something better with this date field. Let's make a structure where we can store the year, the month, and the day of each date. So I'm going to define a new structure. So this stores a single date. And inside my movie structure, instead of date being a character array, I'm going to say struct date. Well, that's confusing. So let me call this date struct. Well, let me call this date with an uppercase letter. Just so we don't get confused which date is which. So this date is the name of the structure, date is the name of the variable, right? So so we're going to have that structure in there. So what's going to change is down here when I want to store the release date, right? I can't just string copy into record_num.date because record_num.date is a structure itself. So Word looks like year, month, day. So let's break that into fields. All right. Well, I'm gonna need to use my string tokenizer again, right? And I'm in the middle of string tokenizing here, so let's break that up a little later, and let's make a temporary variable here. So we'll copy Word into release date. And we'll deal with that later. All right, so when we tokenize the string, we get the release date. We'll copy it into this variable. We'll finish tokenizing. So let's break this up into fields. So how are we going to do that? We're going to use string token again. So I'm going to say Word equals string token, release date, and this time we're splitting our field based on dashes. So that's the year. And I'm going to use scanf. And I'm going to save that in, let's make another variable year. So we'll scan Word with %d and save that in a year. And then I'll continue the string tokenizer by parsing null. So this will be month. And then I'll scan that into month. And then I'll do that once more, and this will be day, and I'll scan this into day. So now I've got 3 integers, year, month, and day. I should be doing lots of error checking. I should be checking these scanfs to make sure my revenue converted correctly and my release runtime converted correctly, and I should be making sure that this works and that I don't get null back from the tokenizers. But I'm just assuming that, you know, every release date has year, month, and day in it. And if I assumed incorrectly, I'm going to seg fault. So this is sloppy code. This is just developing the concept. Alright, so I've got integer values for these. Let's just stick them into our date structure. So, so let's put those in the date structure. So what is this going to look like? This is going to be movie info bracket record num dot date. So that's the date structure dot year equals year. And then the month equals the month, and the day equals the day. All right. So what have we done here? We've pulled out the individual fields, the revenue, the runtime, and so on, and we've stored them directly in movie info bracket record num dot whatever field. For the date, we pulled out that field from the original string. We saved it in this temporary holding area called release date, and then we tokenized release date to break it up into 3 fields. And each of those fields we scanned into an integer, year, month, and day, and now we're putting those year, month, and day into the corresponding fields in the date structure, which is inside that movie structure in this array of movie structures. Right? So this might be complex to wrap our brains around, right? There's a lot going on here, but once we're able to think of this, what do we get for it? Well, we have, a single variable here, movie info, and it's got 100 movies, and for each of those movies, it's got 5 sets of information, and one of those sets of information, the release date itself, has 3 pieces of information, the year, month, and day of the release. And all of that is tucked inside this nice variable here. It's a single entity, and we can pass it to functions and so on and so forth. So let's just clean this up. Release year equals %d, month equals %d, day equals %d. And then instead of just printing arg.date, we'll do argi.date.year, argi.date.month, and argi.date.day. And I'm going to clean this up a little. Now this makes no difference to the compiler, but to somebody reading this, this may be a little easier to match what's going on here, right? We've got movie number, we've got a title, release year, month, day, revenue, runtime, synopsis. And then down here we've got our variables that we're filling in these fields with, but just a little easier to read, just organized a little nicer. So let's see how we do with this compilation. Not bad. So let's run this on the movie database, and you can see, oh, I guess we didn't change it yet, because the release date is still coming out as a string. So let's save that. There we go. Now we got a compile error. So record num is undeclared. So this is line 64. So I'm going to go back to line 64 and movie info bracket record num. And this is the same problem I had before. This should be an uppercase N. Alright, so there we go, run less than movie database, and you can see release year, release month, release day, revenue, runtime, synopsis. And so there you go. Um, so that's an example of using structures. In this case, we've got a more complex structure. We have a structure that actually includes a structure inside itself, and that's totally legal, and that's actually a pretty useful thing to do, and we'll be doing that a lot. Um, first problem set will have you doing this for a database of information related to cities, location, population, and so on and so forth. But the same basic idea. But don't just try to mimic this code, right? Look at this and go back and rewatch the video to try to understand the concepts. But I would recommend don't try to, type in this code and then modify it. Try starting from scratch to write the functions and the programs that the problem set discusses. And that'll be a more valuable experience. And the more you do this, the more natural it becomes to think about data in this way. But in the beginning, it might feel kind of, like there's a lot of moving parts and a lot to keep hold of. Using good names, right? I should have called this release date. That would have simplified things. Using good names will help. Organizing your code, so I put spaces between each token that I was dealing with so that, I don't just have a big long loop with a whole bunch of statements jammed next to each other. Reasonable comments and so on and so forth. So in this course, your coding style is going to be really, really important in terms of keeping track of what you're doing. It's also going to be part of your grade. So you definitely want to keep developing your coding style to whatever makes sense for you. And take your time with these programs. They're going to get big, they're going to get complex. They're not something you want to rush through in 10 minutes. Give them time, think about the organization. This whole course is about how we're going to organize data in memory in a way that pays attention to connections and relationships among different pieces of data. So this is going to be a little bit of a different feel from 224. All right, that's the video on structures. Have fun. Thanks.